I'm gonna be. Good morning, Jennifer. Good morning, and good morning, everyone. I just started the recording, and remember, all the videos will be on my YouTube channel, and they will be public. Uh, and if you ever have any problem with that, of course, you can tell me. Of course. Um, just for today, I want to show you something first. Let me just go to my canvas for this class. And I'm going to share the screen. So let me just go here. Perfect. All right. So I don't know if you have checked carefully the homepage on the Canvas shell, but there is something I wanted to show you. There is something here called Our Ladies right here. Our Ladies is a group. It's a huge group of women in data analysis. If you click here, it will take you to the main web page. And you can see that this organization has multiple chapters around the world, right? So for example, in California, well, we don't have a lot. The closest one is in San Francisco, right? Of course, that's close enough. I mean, 2 hours driving. But these groups, these chapters of Our Ladies are groups that we organize events online. Many times they are online, sometimes they are face-to-face. And some of these chapters are more active, and other ones are more like still growing a little bit. There's another one in San Diego. That one is more active, but of course that's kind of far from us, right? You will not drive to San Diego, but they do online events. What is the idea of Our Ladies? Well, Our Ladies is a group that was born um, or to kind of fight the low representation of women in data analysis and R, right? And is actually creating a lot of products and a lot of things that are very good for data analysis. They have videos, they have advanced topics, and also introduction to some topics. And even if you want to join any group, you can do it for free. I mean, they are not charging anything. Everything in R is free, right? And the idea is to how can I say, to support women in data analysis, because there are not a lot. There's a big gap, and we need more women in this field, right? We need women analyzing data because there are some topics that are biased by gender, and we really need women. And if you have data, if you have information, you have the power to change things in society, right? So if we encourage more women to be part of the R community, and they are programmers and they are data analysts, um, I'm sure that this society is going to be better, because we will have people with data and information to change the world, right? That's the idea. So just check it out. Remember to check this out. And I'm doing this because 80% of the students in the psychology program are women. So you might see that sometimes I give more information for women. It's because they're more in this program, but not all women will study data analysis. Well, you don't have to, right? If that's not your interest. But if you're interested in data analysis, of course, there are groups, there are ways to be more involved in data analysis and STEM fields, right? And even if you're a psychologist, it doesn't mean that you cannot do data analysis. In psychology, we do a lot of data analysis, actually. We trust a lot statistics. And so just pay attention to that. And you might be thinking, how I get involved? Well, there is a page of events right here. And you can check here different events. And sometimes they might add the events here, right? Like for example, this one. This one is in Santa Barbara and Honolulu. It was organized by two different groups. And sometimes there are like monthly meetings related to data analysis, and I don't know, just in case one of you wants to join, of course, you are free to do it. Some groups are in Portuguese, but I don't know if any of you speak Portuguese or you want to speak Portuguese. It's right here. But there are different groups, right? Actually, look at this. If you scroll down, there are many more, right? Many activities that you can join online. So some of them are face-to-face. So of course that will be impossible. But what is this? Meetup, yeah. So yeah, just check it out if you have any spare time. I think it could be a good starting point if you want to go deep into R and data analysis, right? Now, let me just change the why I don't see the gallery here. Oh, right here. How can I see the gallery? Just 1 second here. Just want to see gallery. I cannot see it. Weird. All right. I'm gonna be checking if there's any question anyway. Let me just check the chat. Any comment or question? No. Okay, we are good to go. Cool. So now, you might remember that I started explaining this assignment number 2 in our last session, right? And you can watch the previous video, of course. I think I already submitted the video. I'm not sure. Let me double check. Let me double check if I already published that one. October 31st. Yes, it's right here. So remember that in this session, I started explaining assignment number 1. Sorry, assignment number 2, right? I'm not gonna, of course, cover again that content, but I didn't explain, I didn't have time to explain question number 9. And let me do that. Because there are several layers of complexity here. It's not complex. I mean, it's not difficult. It's just I need to explain some details, right? So in this question number 9, I'm giving you a new data set that I call the OUES data. You can get access to this data set by clicking here, and you can download the data set. Or if you are using R, you just need this code right here. And this code will open the data set in your R session, right? If you're using R, you don't have to download the file, right? The data file. So why I call it OUES? Well, because in this data set, I calculated something called the oxygen uptake efficiency slope. And let me explain you how we get those numbers. And where is the VO2 peak here? So the way we get those numbers is by making people to do a heavy load of physical activity. And we connect people to, well, we connected our participants to this little device right here that is going to capture the level of oxygen and carbon dioxide, right? So the machine will do a transformation of the data, and it will give you something called the VO2 peak. This was a study that we did a long time ago in Costa Rica, and also we did the same in the United States. And I must tell you that this data is only, in this data you will find only people who are older adults. So all the participants are 60 years old or above, right? So in this data set, you will see people who are 80 years old. And yes, we made them walk and actually run very fast connected to this machine. And they had some electrodes here where we were measuring heart rate and other measures, right? It was a very expensive study, and I'm very proud of this because it was a lot of work, and we are still working on this forever, I guess, on this data. So thanks to this VO2 peak, which is the maximum amount of oxygen that a person can take under a stressing condition. Stressing means that you ask the person to go fast, very, very, very fast. It could be a bike, a stationary bike, or it could be a treadmill, right? So you ask the participant to go very fast, make their best effort. You have to pressure the person. You have to push pressure on the person, right? Like encourage the person to go faster, even if they're older adults. It's kind of difficult, but I mean, you can do it. And so that's how we measure the maximum level of oxygen that their lungs can take, right? Their body can take. So thanks to the VO2 peak, we are able to measure or to calculate this oxygen uptake efficiency slope. So this oxygen uptake efficiency slope is something that has shown better properties to predict, for example, cardiovascular disease, right? Or to predict the correlation between cognition and cardiovascular fitness. So I calculated this one while doing some equations and regressions, and I calculated this one, right? And I did that from having the information about the VO2 peak. Well, why am I telling you this? Well, because you also have to think about research topics in the future, right? And especially if you're thinking about taking seminars with me. So I will always give you the whole story, so you can have an idea of what type of things you can do when you are learning how to do research, right? Of course, we don't have the VO2 peak machine, right? The VO2 measure. We cannot do that at CSU. That would be very expensive. It would be nice if we had a lab where we can have people and measure the levels of oxygen and cardiovascular fitness. It would be amazing, right? But we don't have that. But you could do some sort of approximations. Like, for example, if somebody has a smartwatch, the smartwatch sometimes will give you an approximation of the VO2 peak. And you could eventually measure that in your subjects, in your participants, right? Like, for example, the Garmin watch, and I believe the Apple Watch might have an app that tries to approximate the calculation of the VO2 peak, right? Of course, it's not the best measure. It has a lot of error because it's measuring everything from the light that is captured by the watch, right? It has a laser and, well, the whole story. But yeah, in this data set, what we have is these two important variables. We have these very expensive variables, OUS and VO2 peak. They are very expensive measures, right? And very valuable. And these are all older adults, right? All the observations in this data set are people who are 60 years old or older, right? Which is nice. As I said, this type of data set is very hard to find. And I love using this data set for teaching. This is my first time actually adding this data set to the list of data sets for this class. So let's see how it goes. Let's see if it's useful or not for your learning process. So in this question number 9, I assigned you the task. I'm giving you the task of finding the best model that you can get out of this data. And I'm giving you information about all the variables that I believe you can do some experiments, right? For example, I'm explaining here the Stroop color task, right? And I don't know if you're familiar with the Stroop color task. Has anybody done this or has been evaluated with this? Do you remember something? No? Have you seen this task in other classes? Probably in cognitive related classes, something? Nope, nobody? Let me check. Okay, Laila says no, that I can remember. Okay, cool, that's good. Let me explain you what it is. And this is a good place to start. So I have a score of the Stroop color test. Let me show you the Stroop color test. If you click there, you will find an example. This is a very common test that we do in cognitive psychology in order to measure the capacity of dealing with interference, right? And in our everyday life, there's always noise, right? There's always something that causes noise and kind of distract our attention from the task that we are doing, right? So that's called interference. So we as human beings are able to isolate that interference, that noise from the environment, or even from our brains, from our minds, and just focus on something that we really want to do, right? So that's something that we call interference. For example, if you try to study mathematics and somebody is listening heavy metal, right? Probably that's distracting for you, right? You don't like heavy metal. You don't enjoy heavy metal, probably. Well, I do, but probably you don't, right? And of course, you feel that annoying, right? So you have to focus more. You have to use more resources from your mind, from your brain, to hold the attention and study math, right? So you have a high level of filtering your interference, right? The interference from the environment. How do we measure that? Well, this is a proxy for that. This is an approximation to measure that capacity, and we call it the Stroop test. It is called Stroop because the guy who created this test was named Stroop. Well, his last name was Stroop. So what people have to do here is to read the word without paying attention to the color, right? In this case, it matches totally fine, right? Blue is blue, right? Yellow is yellow, right? But there is another part where the color and the word don't match, right? So you have to say red, for example, in this case, let me just make it bigger. You have to say red without saying green, right? Because your brain might try to say green, right? And in the other stage, you will have to say the color without reading, right? There are different versions of the Stroop, right? And there's another set where people will ask you to say the color of the letters without reading the word, which is more difficult, right? So if you try to say yellow without reading green, for example, it kind of gives you more interference in your brain, right? You can try at home, right? You will see that's kind of difficult, right? And if you're young and if you do exercise, you sleep fine and everything, this is a very easy task. But for older adults who might have initial symptoms of dementia, or for other adults that are not stimulated in their environment, right? For these older adults, this will be complicated, very, very complicated. And they will make a lot of mistakes and they will delay a lot of time, right? So what we measure is mistakes and how much time it takes for them to finish the task, right? And older adults with high levels of dementia or very advanced in the dementia stage, they don't finish this task, right? So this is the Stroop test. And probably you have seen some pictures similar to that one on social media, right? Some people are sharing some pictures that are very similar to that. The other task that you will find here is the trail making test. And I mentioned this test the other day, in our previous lecture, right? So people have to match, well, they have to associate or to link together the numbers in order, right? So for example, somebody has to begin here, right? Oh, sorry, that's not what I meant to do. Right? This has to go in order. So without stopping, they have to go very fast and finish the task, right? The same happens in this case, right? In the second part. In the second part is more complicated because you have to link 1A, 2B, 3C, and 4D without stopping. The person cannot stop, right? He or she cannot leave the pencil, right? The person has to go without stopping. The fastest the person can do it, right? And let me just delete this. Can be annoying. And of course, that type of test is bigger enough right here, I believe. Where is? Ah, right here. Right? This is the big page where they have to do all this. And you might be thinking, oh, that's easy. I can do that. Yes, of course, because you're young. And probably you have all your life. But for older adults, this is a good indicator of dementia. Lower scores in this test are a good screening for dementia, right? Or low cognitive performance, right? Um, Another test that you will find here is the digit symbol substitution test, which is right here. And actually, I believe there's a picture here. Let me make it bigger. So in this test, you have, well, the participant has to write the symbol associated to the number, right? So for example, in this case, if you see an empty space here underneath number 2, you have to write, for example, this little symbol here, right? So it would be something like this. Sorry, it's like a double-headed arrow. If they see 9, they have to write this symbol here. So let me write it out here a little bit. It's like a inverted E. If you see 2 again, you have to write this symbol. If you see 3, and so on. But there is a limitation of time, right? Sometimes in some versions of this test, you will give them some amount of time, or in other versions, you will allow them to last as long as they can, right? Or as long as they need, right? So, and you track the time, right? The longer you spend on solving this problem, the bad you are in your cognitive performance, right? So, and this is a good indicator of dementia as well, right? Or it has shown to be a good indicator of dementia if you last longer here compared to other peers, right? And let me see if I added more here. Oh, I didn't add the SRT free recall trial. I didn't add a link for that one. But this one is about, this is the SRT. It's a test where you will give them a list of words. You will actually read the list of words. And you will ask the person to remember as many words as the person can after, I don't know, 5 minutes, right? And then you ask them again to remember any word after, I don't know, 30 minutes, right? So what we are trying to do is to measure short memory, long-term memory, and sometimes logic memory, depending on the task, right? So yeah, that's kind of the test. I didn't add any example. I apologize about it. Probably I forgot it. And we have another indicator that we call logic memory. That's another variable in this data set. And in logic memory, what we do is to narrate a story, to tell a story to the participant. And after some time, we will ask them to remember details about the story. What we evaluate is if the person can remember the story in a logical order, right? And you might be thinking, ah, man, that's easy. I can do that. Of course you can. But again, these are tests designed to also capture problems at the cognitive level, right? Of course, many of you will do this type of test totally fine, and probably you will not spend a lot of time, right? But in older adults, it's different. When we get older, our brain works in a different way, right? So that's why we created these tests. Well, there's another story behind this test, but they can be used for screening any symptom of dementia, right? In this data set, you will also find variables like total body fat, which could be a predictor of many things, right? And we have another variable that is named country. So in this variable, number 1 represents Kansas, and number 0 represents Costa Rica. So in this data set, we have 2 samples, right? One from the United States, that one actually comes from Kansas, and the other one comes from Costa Rica, right? We also have body mass index. I don't know if you're familiar with body mass index. I don't know. Are you familiar with the body mass index? Should I explain it? What do you think? It's fine. You can tell, no, I don't know what it is. A little. Okay. Let me just explain you what it is. Thank you, Mark. It is okay. So the body mass index, BMI. Let's go to Wikipedia. I love Wikipedia. So in here, the calculation should appear around here, right here. So the body mass index is just a proportion of your weight. It says, isn't to calculate someone's body fat or someone else's weight related to their height. To see there, please. Yes, Mark, it's something like that. You are correct, but it's not about body fat, actually, because body fat is not well. It's kind of captured by BMI, but it's kind of an approximation to body fat, to be honest. What is taken is your weight, and you will divide your weight by your height. You are correct, Mark. And then you multiply this by a constant right here, right? If you are using pounds. If you are using kilograms, you don't need that constant, I believe. Yes, you have to add that constant number because this is in pounds and feet, right? But we normally use, well, internationally speaking, we always use kilograms and meters, right? Because it's easier. But in the United States, of course, you love the imperial system. So yeah, this is body mass. And what is the importance or the relevance of body mass index? Well, this, as Mark mentioned in his comment on the chat, it has been helpful to predict if somebody is obese or if somebody is at the right weight, right? Or healthy weight. I don't know if there is right or wrong, but at least there is a healthy threshold, right? I don't want to say right or wrong because that sounds like body shaming and I don't like that. But I would say that there is a level where it's healthy, right? There is a weight that is healthy for many people, and that level changes, of course, depending on age, depending on gender, well, or biological sex, right? And it depends on other factors, right? And of course, we can classify people as normal, overweight, or obese, right? And you might be thinking, why am I talking about this in psychology? Why this guy is talking about these topics? It sounds like I'm taking a kinesiology class, right? Well, that's because our brains and our minds are connected to our bodies, and we need to study variables that are related to our global health, right? Our mind is not isolated from our body, right? So, and that's why we need to take into account other variables that might predict cognitive performance, right? And also, you will find heart rate right here. Oh, I didn't talk about this. In this data set, there is another variable called 6-minute walk. I just call it 6_mean walk. What does it mean? In this evaluation that we did with other adults, we asked the participants to walk for 6 minutes in a circle that was, how can I say, labeled by distance. So what we did was to measure how many yards these other adults could walk in 6 minutes. And you might be thinking, well, that's an easy task. Yes, of course. But for a 80 years old older adult, right? For a 80 years adult, it's a challenging task depending on the health status, right? And we found that by asking this to the participant and just register, just how can I say, keeping track of the distance that they can walk or run in 6 minutes, that is a good predictor of cardiovascular fitness, Yeah, just for 6 minutes. That's kind of interesting, right? And we found in other tests that we did that it was a very good predictor. So we kept doing it because it was working in our team back then. So in this data set, you will find the distance in yards that they walked in 6 minutes. But not only that, during the 6-minute walk, we were tracking the heart rate. So you will find another variable that is the maximum heart rate during the 6-minute walk, right? We had what's the name? This little clipper that you can use in your finger to measure, of course, the heart rate, right? So they were walking with a little clipper, right? And also you will see in this data set the heart rate before 6 minutes walk, right? Because we wanted a baseline, right? How was their heart before, right? And if there is any change after, of course, well, during the task. There was another heart rate measure that was after the 6-minute walk, but for some reason, I don't know why I didn't see that variable in this data set. Probably I forgot about it, but that's okay. We don't need it for this exercise. Now, after this boring explanation of the data set, let me introduce the task for this question, right? So the idea, as I said before, is to find the best model for this data. And I explained you that there are different ways to find the best model for the data. You might have a theory behind the data and you want to follow the theory, and you don't need to explore the data. Or you don't need to empirically find the best model. You might have a solid theory behind, so you can follow the theory. Or sometimes you don't have theory, you are exploring the data, right? You could explore the data by using model selection strategies. And let me tell you about it. So in here, the idea is that you will select an outcome and you will select the predictors out of these variables. I will not tell you what is the best model. You will try to find that. But it has to make sense. You don't have to throw any variable into the model because it doesn't mean anything, right? I mean, if you do that, well, you can just ask ChatGPT to do it and ChatGPT will do it because it's a machine, right? For example, but you are not a machine. You're a human being, a researcher, and it has to make sense, right? So, oh, I also have here gender. So your task is to create a model. I will not tell you what model you can pick. You will have to find one, right? And as I told you, it has to make sense. So for instance, in this case, I'm giving you this piece of code, and I'm telling you that if you're using R, you can just copy this code. And actually, let me give you an example. Let me explain this example first. Let me just go to R first. Let's go to R Studio. Let me just close this. I was working on a report. And let me make this white because sometimes it can be annoying for some people to see this in black. Let me just change it to Chrome, probably. Yeah. Okay, that probably looks better. Let me clean my session. All right, and let me create a new R script right here. Well, actually, let me do it with Quarto because that's how we are working in this class. So let me just call this. I want to call this exercise 9. Oh, actually, I misspelled the word. Question 9. That will solve no problem. All right. And the author is me. You know how it works. And let me just delete all this. I don't need it. Oh, just one thing. Let me delete this annotation that I did here. Let me erase this part. Yeah, that's perfect. And in here, of course, this is question 9. Oh, and let me make my window a little bit bigger. Let me zoom in a little bit, not too much. All right. So the first step is to insert a chunk of code in R, right? After that, you need to open the data. And the code that you need is right here. Perfect. So let's copy this data, this code. You might remove this or you might keep it. I will tell you what it is. But for now, I'm going to delete this part. All right. If I run this piece of code, I click here where it says like this play, little play green symbol. Ta-da, the data is here. I named the data OEUES data, right? You can use any name. I don't care, right? You can use any name for this object, but my object is called UES data. What I'm doing is using this link, right, to open the data from my repository. So this data, if you copy this into a web browser, let's imagine that you copy this into the web browser, then you just remove the quotes. It looks like this online, right? It looks like a flat file separated by comma, right? Each comma is a column. So this is how it looks like. But R will transform this into a data frame that human beings can read. Excel would do the same, or any other software that works with comma-separated files will do the same, right? It's not something magical from R. I mean, any software will do it. All right. Now that we have the data inside, we can start. Let's find the best model. Right? And let me come back to where is, sorry about that. I have other things open. Let me just close this. It's distracting my brain right now. Okay, cool. Now we're here. Now you will need two more pieces of code. You will need this one piece right here. You will need the package mass. So if you ever see a package, well, if you see the name of a package, because you see the function library, you have to check that you already have this package in your environment, right? Probably you haven't installed this package yet, right? So you will have to install it first. Tidyverse is already in your computer because we have been using this package a lot in this class. So you don't have to install the package again. The only one that you need to install is the package mass. So let me just copy this piece of code and I will show you how you can install the package. All right, let me just create another piece of code and then it's right here. So this package mass can be installed by going to packages right here on this tab. If you are on your computer, you can do it now if you want to. If not, you can do it later. You go to packages and then click on install and then just type mass. And look at that, it's right here. And then you click install. Always remember to check this box right here. It's very important. If you uncheck this box, you will get in trouble. Why? Because packages in R will borrow information from other packages, right? So that's what we call dependencies. So one package depends on the other because the author of the package decided to take some pieces of code from different packages. So that creates a dependency. So if you don't have the dependency installed, the main package will not run, right? Oh, actually, it will not be installed. So always check that, right? And then you click install, and that's it. It will be installed. I'm not going to install again the package, but you can do it at home, right? Now, once the package is installed, you can press Ctrl Enter to activate the package, right? And also this one, we will need this one for this exercise, right? So both are there, perfect. it says that everything is fine. If you see these letters, right? Attaching package mass, and this is fine, and this is fine too, right? There is no error. Now, let's copy this piece of code. But first, I'm going to explain you what is happening in this piece of code. And I didn't have time to explain that when I wrote this. So I'm going to explain this verbally. In this task, well, in this code, what I'm doing is taking my object and selecting the variables that I want to test as possible variables in my model, right? In this example, I'm selecting only the variables OUES, PU2peak, and the WISE test block design, the WISE test and digital symbols, and heart rate, maximum heart rate during the 6-minute walk, right? So I'm selecting those ones. Why am I doing that? Well, because this data has missing values. Let me show you. Let me show you when I mention missing values. So if you check here, oh, sorry, resume sharing for some reason, stop. Okay, if you click right here in this little box on RStudio, just in case you're following this, you could do it just by copy and pasting code, right? You can click here and you will find the variables in a column mode, right? So look at how many missing values I have in this data set, right? For example, the struct color has several ones. And you might be thinking, why? Well, as I said before, some other adults were not able to finish the task. So they become NAs. Oh, again, sorry about that. They become NAs or missing values. Remember that in R, missing values are represented by NA. So these people didn't finish the task because, of course, they were not able to finish, right? Some of them were very old. Some of them were 90 years old, right? So it's difficult for them to finish all the tasks. So it's normal to have missing values. In this case, this variable, I don't know why it has a lot of missing values. Probably was not recorded carefully. So we are not using this one anyway for selecting the best model. But we are using these ones, struct color and trail A, right? And they have missing values. The problem of having missing values is that when you are comparing different models, when you are trying to evaluate different models, you have different combination of variables. That means that you're using a different sample out of the sample, right? So for example, well, for instance, let's imagine that you want to use this variable, trail A errors in your model. You will lose a lot of people, right? They will be dropped out from the model because they have NAs in this variable, right? If you delete this variable from the model, let's imagine that, you would have more people, right? Because they didn't miss a lot of people. So it's like creating a subsample, and you cannot compare models when the sample is different because of missing values. So because of that, in this example, I'm selecting the variables that I want in my model, right? The ones that I want to test. And then I'm dropping the people who have NAs. You have to do that. You cannot compare multiple models if there are missing values, right? So that's what I'm doing. It says drop NA. That means that I'm dropping all the people who have NAs, right? In that way, I get a clean data set without missing values. And you might be thinking right now, hey man, why you didn't clean the whole data set? Why you're making me doing this? Well, because I want to give you a real example from real data in a real situation. When you are doing a research project, you will have a lot of missing values. So you have to be aware of that all the time. Well, depending on the topic. For example, if you are asking questions about income, of course, you will have a lot of missing values. People don't like talking about income. Never. And they are paranoid about it too. Nobody wants to be asked about income. So, of course, if it's something about income or household income, you will see a lot of missing values, right? Or if you're talking about complicated topics, like, for example, sexual behavior, for example, has a lot of missing values, or sexual thoughts, for example. or everything that is about sexual behavior many times has a lot of missing values because people don't want to answer that. And the correlation with religiosity is very high too, right? So, of course, you will see a lot of missing values depending on the topic. And you have to be aware of that. That's why I make you do this. Of course, I could clean the data and give you a clean data set, but that's not realistic. That's not how real data works. All right, so if you want to solve this question, you just have to copy this piece of code and open, or just insert a new chunk of code right here and put it here, right? But you will have to change the variables right here because your model is going to be different from this example. This is just an example that I'm giving you, right? And I will explain you the example more in details. But in this case, let's imagine that I want to change a new variable here. I don't want to follow this model, right? So let's try to replace, I don't know, probably, let's replace, well, actually, let's add another variable. So instead of only these variables, let's add another one. For example, let's add gender. And actually, I can also add country. Which is country here? Oh yeah, country is here. So let's add country and see if that's a good predictor for my outcome, right? Perfect. So I added a new variable, or you could delete any variable you want. But look at how I do it. Each name is separated by comma. If you miss a comma, you will get an error saying, hey, man, I don't know that object. I don't know what you're talking about. So R gets confused. So you don't miss commas. Never miss the commas. That's very important in R, right? Especially in this object. The only thing you have to do is copy and pasting, and then just replace the name of the variables. The variables are here, right? This is the name of the variables, and also they are also written here. You can just copy and paste because they are actually from the data set. So you can just copy and paste. Now, let me run this code first. Let me show you what happened. Now, if you run the code, you can press Control Enter or Command Enter, or just click on this little play button right here. Either way, it should work fine. Look at what happened. Now you have another object. This new object has the name OUES data no missing. That's how I name it. You can use any other name. In my case, I'm just using this name. You can keep the same name for the sake of learning, right? If you see the same name for the practice and your answers, probably is easier to understand, right? I might recommend to keep the names. And look at the new data set. Now it has 131 observations. Before filtering the missing values, it was 144. We didn't miss a lot of people, right? Which is good. It's always good if we don't miss a lot of people, right? If you miss people, that's more uncertainty for your model. You don't want to lose people, right? So that's something important for this model. We will have uncertainty, but not that much, all right? Perfect. And now this data doesn't have any missing value. Actually, let's open it and you can see it. All the columns, look at that. They don't have any missing value, right? Because I dropped all the people who had missing values, right, in these variables. So everything is completed, right? Now, we need to think what's going to be the model, right? I haven't told you what model I'm testing. I'm just telling you how to select the variables, right? In my logic, oh, that's something I didn't want to do. What is that, by the way? Well, it's just a IRB and procedure. All right, so let me show you the model that I was running here. In this case, what I'm doing is to try to predict the score of blog design. And actually, let me see if I added an item for blog design. Ah, look at that. No, I didn't add. Let me show you what is Waze blog design. Let me see if there's any picture around here. I just need a picture. Images right here. This is block design. This is a task that is part of the Wechsler intelligence scale. It's very famous in psychology. We use it a lot also in education, right? So the person who answers the test has to complete the pattern with blocks. And there is a limit amount of time, right? Sometimes it's like 3 minutes or 2 minutes. I don't remember. It depends. It depends on on how you want to evaluate the person, right? So the evaluator will give to the participant a disorganized number of blocks, and the person has to replicate the patterns, right? If the pattern is this one, the person has to replicate that one. And of course, each design is going to be more complex, right? So let's imagine that the person solves the first block, right? And it's very easy. Then the next one is not that easy. The third one is going to be harder. The fourth is going to be way harder because it has a lot of patterns, right? So what we measure is the amount of time, as this picture is telling you, right? So it might take a lot of time to do a very complicated figure, right? And so what I'm doing here is trying to find the best predictor for the block design test. And you might be thinking, why? Well, the block design test is a good test that measures working memory, right? It helps to measure working memory. So my measure, my outcome in this case, which is block design, it's an approximation to working memory, right? It's kind of one indicator that I can use to measure working memory. So in this example, what I'm trying to do is to see if, for example, VO2 peak, OUS, and digital, this is a digit and digit number matching, and heart rate are related to my working memory test, right? And why am I doing this? Well, because I already know that your cardiovascular fitness could be related to your performance in working memory. And actually it is. People who do more exercise. Oh, I'm sorry about that. Oh, Jesus Christ. Wait a minute here. I'm losing my internet again, I guess. Let me do something just in case. Okay, I name a person a co-host, so just in case the meeting drops, and that person is going to be the host while I reconnect again, and we don't lose the meeting, right? It was you, Layla, again. So Layla, I just name you the co-host, just in case my connection drops. All right. So I was telling you that, I was telling you that these are my predictors, right? And let's see if that works, right? I might be wrong. Probably these are not good predictors of working memory as measured by the block design test. And let's do that. Let me just copy the code, and I will explain you more details about this code. Let me just create a new chunk of code right here. I just inserted that one. And let me explain you what is happening in this code. For model selection in R, we are going to use the function step AIC. Remember that the AIC value, it's a fit measure that we use to compare different models. I don't know if you remember the lecture. I told you that a lower AIC means that the model fits better the data, right? So given that I'm using this function, I need to pass a model to the function. In this case, I'm using this model as my starting point. And actually, look at how it starts. It starts without any predictor. There is no predictor in this model. It's just a mean. This is something that we call the intercept model only. It's just the mean of, or the estimated mean of block design, right? Why am I doing this? Well, because I want to start building up the model. So what's going to happen, let me just draw that probably. Let me just, actually, no, let's do this with, let me see if Zoom is working. There is a whiteboard here. Reactions, stop recording polls. Oh, and annotate, probably. Oh, I don't see the whiteboard here. Let me see. Doesn't show me the whiteboard. Okay, that's fine. For some reason, it doesn't show it. Let me just open a new file here. This is what's going to happen. Let me just open this. 1 second, please. Sorry about that. I love this tool. Actually, this software that I'm using right now, and just a parenthesis here, is something that you can also use for your assignments or anything you want to explain. Is a free tool for diagrams, and I use it a lot for teaching, but also for publications. I create diagrams with this tool. It's free, open source, and I think that the final product looks fine. But let me show you what's going to happen. So what's going to happen is that my outcome is, and let me just create a little square here. My outcome is block design, right? This is my dependent variable, right? Block design, the score actually in block design. No, block adding now. Yes, block design. Let me make it bigger. I just need something bigger. Yeah, that looks good. And also, I will start with nothing, right? So I will start with a model that is actually empty, right? There is not any predictor here. So it will look like this, right? Let me just create this little tilde a little bit bigger, like this. Let me delete this. So there are no predictors on this side. It's empty. So what's going to happen is that little by little, let me create another model right here. In the second model, it will add another predictor, right? Or at least the first predictor. And then the software will evaluate if the AIC value is better compared to this one, right? So for example, if this model with one predictor is better, the AIC will be lower compared to the AIC in the first model, right? AIC1. So let's call this AIC2. So I have two AICs, right? This one will produce a AIC value, and this one will have another AIC value. So what we are comparing is if adding a predictor actually helps to explain the data. Now, in the second iteration, the software will add another variable. So what's going to happen is, let me just, Jesus Christ. Yes, that's what I want. In the second iteration, now right here, it will add x1 and also another predictor, x2. Right? Just do a plus sign here just for fun. Plus sign here. Let me make it larger. probably 36, right? So now we are going to compare this model versus this model, right? Now I have two predictors. So I need to evaluate if a model with two predictors is better than the model with only one predictor, with only one independent variable, right? And so on. So the software will add more and more variables until it finds the best model, right? That's what R is doing behind the scenes in this piece of code. And as you can see, there is an argument called scope. A scope means that you are saying that the most complex model that a function can fit is this one, right? This is what we call the saturated model, right? The model that has all the variables that you want to test. The lowest model or the simplest model is a model with only the intercept, like the one that you are seeing here, right? So we are telling to the model, yes, this is the how can I say, the biggest model that you can estimate, and this is the smallest model that you can estimate. So we are telling the route, we are telling the path that the function can follow, right? So what the function will do is to try to add each variable one at a time and calculate the AIC. Now, in this function, what I'm doing is running this in both ways. So in the first step, the function will try to trim this model. So it will try to just estimate the full model and then trim the model, cut the model. And then it's going to do another round where it's starting from the lowest model up to the highest model. So it will do both, what we call backwards and forward. That's how we call it, or from top bottom and bottom to top, because I'm asking to do both. And you might be thinking, why am I doing that? Well, because the order sometimes matters. So that's why we want to make sure that the final model is really the final model. And one good way to do it is by just declaring in the function both, right? Which is nice. So the software will do everything for you, right? That makes your life easier. And actually, what we are doing here is one step that is important for example, large language models, or what we call these days AI, right? You are kind of doing a semi-selection of best model, similar to what you would do in AI approaches. It's not like this, but the logic is the same. I don't like the term AI, but people are using that one a lot for many reasons, but it's fine. Okay, so you are specifying a model here, a full model, and the smallest model here. Let's come back to my code right here on our studio. Remember that I added this new variable here. So now I will have to add that variable also to the biggest model possible to be run in this data set, right? So I'm going to add country here, right? This part is the same for all of you. You don't have to change it. The only thing that you will have to change sometimes is this model right here. As you can see, I'm using this object and passing the object right here. Look at that. Why? Because it needs a model where it should start looking for the best variable. So I'm starting from the basic model, right? So if you change your outcome for your model, and you have to change this name right here, right? So let's imagine that you don't want to do waste block, and you want to do as an outcome digital search, right? Or digital match, right? Let's imagine you want to do that. So you change, oh, sorry, not there. I apologize. I meant to do it here, right here, right? So that will change the order. And let me change waste the SS. And then now this one is going to be a predictor. Perfect. Now let's run this model. I'm going to run this by pressing Control Enter. And then the other piece of code, pressing, actually, we can use this as true, and you can see what happens. So if you say trace true, look at that. It will show you a table with all the combinations of models that the function is running, right? Which is awesome, right? So for example, it started with a model with only the intercept, right? And then it added little by little all these functions, right? Then it added, it tried a model with country, right? As the only predictor. Then it tried country plus VO2 peak. Then it tried country plus VO2 peak plus Waze, well, block design, right? And the final model is, let me double check here. Oh, I need a piece of code that I missed, this one right here. You might use this function, model parameters, if you install the package parameters. Right, I'm going to call the package. But if you don't want to use this function that comes from parameters, you can just use the native function in R called summary and just pass the object to the function. Either way should work fine. But if you want a pretty table out of your final model, you can use parameters, right? Look at that, model parameters. Or if you want a kind of an ugly table, this is the natural table in R, you can use summary and it will also give you this table, which is the same information, but this table looks nicer and it has confidence intervals, which I love the most. I really love confidence intervals. So that's something to take into account. So let's see what happened. Oh, wow, it's a very good model. Let me explain you what is happening here. Look at what I did. So after testing different combination of models, the function said that the best model is a model where country, VO2 peak, and block designs are the predictor of digital symbols, which is another measure for working memory, right? Digital symbols also measures working memory. So it's kind of nice, actually. I did not know that would happen. And look at this. It's telling me that there is a difference by country. In this data set, Kansas is coded as 1, and Costa Rica is coded at 0. So it means that it's telling me that the mean difference is 11.25 after controlling by these factors right here. So in simple words, people in Kansas have a better score compared to Costa Ricans. They have a better performance compared to Costa Ricans, which is totally the opposite that I was expecting. I was expecting to see a better score for Costa Ricans. But in this case, in the test for digital symbols, it didn't happen, right? So Kansas has a better score, actually 11.25 points more compared to Costa Ricans, right? And this is the best model that we can get out of these variables that I selected, right? Also, VO2 peak, look at that, it's a good predictor. And actually look at the p-value, right? And the confidence intervals. So it's telling me that the VO2 peak on average changes at 0.63 at a rate of 0.63 points, right? So that means that when VO2 peak goes up, the score on digital on digital symbols also goes up, which is interesting. So it's telling me that the amount of oxygen of these people is also related to the score in a memory test, right? In a working memory test, which makes sense, right? It's the connection between body and mind, right? So if you are more fit, right? If you're better physically speaking, your memory score goes up. And of course, the score of block design is positively related to the score in digital symbols. Why? Well, because both measure the same thing. Block design and digital symbols are measuring working memory. So of course they are related, right? I was expecting them to be related because both are measuring the same thing, which is working memory. That's our construct in this case, right? So and look at the confidence intervals, right? It's telling me that the real number, the real slope for the relationship between block design and digital symbols is a number that goes from 0.06 to 0.35. It is a number between these two, but 0 is not a likely number, right? So that's good. That is telling me that 0 is not possible in these confidence intervals. So it's telling me that the relationship between between block design and digital symbols is not explained by chance, which is also quantified by the p-value, right? The p-value is less than 0.005, right? It's a tiny number. Similar happens here, and similar situation happens here, right? But look at what variables it dropped. The function dropped. The variables heart rate max, and also it dropped where is and OUS is not in the final solution, right? Even though it tried to keep it, of course, when you add those variables, the AIC goes up, and we don't want that, right? So yeah, this is the best model that I could get so far out of this data, right? In your case, and you might be thinking right now, or you will think about this later, probably right now you're washing the dishes or doing something else, so probably you're driving right now, I don't know. But once you try to answer this question, you will have plenty of questions, and you can send me an email. But let me tell you the first question that you will have, and I'm very sure you will have that question. The first question is, okay, I have all these variables. How the heck I start creating a new model, right? So the answer is always read the information about the variables. And if you have questions, search online. Search for scientific papers about it, right? It's kind of a task that I'm giving you also, I want you to think more as a researcher, right? Not only as a data monkey. You can be a data monkey and just throw variables in a model. Like I said before, like creating a soup, right? You can throw a lot of ingredients. The soup might taste ugly, but at least you got a soup. But we don't want that. We want a very tasty soup. So I want you to think about it. So, and I give you some clues about it, right? For example, everything that is about cognition probably should be an outcome, right? Everything that measures cognition. Like, for example, Stroop color, trail E, trail B, OUS. Well, no, not US, sorry. Block design or digital symbols. They are all logical memory. These are all cognitive tasks. And probably it makes sense to say cognition can be predicted by physical performance, right? And of course, by other cognitive measures. So I want you to create a different combination of models. That's what I want you to do in this item. And I'm giving you a lot of freedom, so you can do whatever you want, right? But remember, you have to interpret the results. You have to tell me the interpretation of the results. And if you have questions about it, of course, we can meet on Thursday or the next week as well, and I can help you, right? And actually, I can take one of your examples and explain the class and the interpretation, right? We can do it together, right? So, or we can discuss possible models. you can tell me that in the next session, I'm thinking about this model. Does it make sense? And we can discuss the model, right? The idea is to think about data in terms of theory, right? It's good to select models, but it's also good to think about what is the implication of the model. How do you explain that, right? So this is my first attempt to create that type of conversation. All right, any questions so far? Any question is totally welcome here. You can type or you can just talk. It's fine. Either way, it's fine. Everything good? Okay, cool. I will interpret that as everything is fine, as everything is good. You might have questions later, and yeah, you might send me that. Now, with the minutes that I have left, I'm gonna try to explain how to solve this problem in Jamovi. All right. I would encourage you to use R for this problem because R will make your life easier. As you can see, just run the code and the final model is going to be selected by the function. You don't kind of have to do a lot of things. But in Jamovi, you will have to do a lot of things. And let me show you. Let me just download the data. Download the data from here. So if you click on this link, oh no, it's not this one, sorry about that. This is the presentation. The data is right here. Yes, right here. Sorry about that. So you will see this little cloud here. And then just download the data. It will take some time, I guess. Yeah, now it's completed. Where did it save it? I didn't know. Downloads. Okay, cool. All right, let me just go to Jamovi. As you saw, you have to download the data. Let me open Jamovi very quickly. It will take some time, as always. All right. And let's go to these little 3 lines and click on open. And then I'm going to search the dataset that I need. Jesus Christ, it's very slow today. Why are you doing this to me, Jamal? Oh, that's embarrassing. For some reason, it doesn't want to open the data. Oh. You might have the same problem in probably Google Chrome sometimes. Sorry, on Chromium for those who are using Chromebooks. Probably you're having the same problem like me. Let me check if there's another window around here. Oh, wonderful. Doesn't want to open anything. And I don't know why. Let me just stop sharing. Let me try again. Probably it's because of that. Jesus Christ. Open. Okay, let me just open this in another way. Oh, it's right here. It's there. Okay, I made it. Okay, so let me just share my screen again. I made it work. So in Jamovi, it will look like this. All right, it is, it's kind of ugly. Of course, we have empty spaces because they are missing values, right? So Jamovi by default will understand that empty means missing, right? That's the meaning of empty in this case. All right. And let me check if Jamovi will filter out the people. Yeah. Well, let's see what happens. So you go to linear regression, because that's what we are doing. Remember, we are feeding a linear regression on continuous variables, right? All of these variables are continuous. That means that we are assuming there's a continuum of scores, right? So as dependent variable, and I can use, for instance, well, actually, I can go to model builder. But yes, my dependent variable will be, in this case, let's use the same one. Where it is, 6-minute walk, trail we was this one. And my predictors have to go here into covariates. So let's pick the covariates that I want. It was female. Let's add age. Why not? And we can add fat total. Let's see if that works. And stroke color. Why not? I'm changing a little bit the variables. And then add the covariates here. If you have any factor, that means if you have any how can I say, nominal variable, right? It has to go here. So for example, if you want to add female, actually, female shouldn't be here. Female should be here. Because this one is a dummy variable, it's a nominal variable, so it should be under factors when you're using Jamovi, right? And look at that. It's telling me that I can add blocks. So what I'm going to do is to build up my model. So I'm going to remove from my first block all these variables, because I want to create the model little by little. So I'm going to start with one simple model where my only predictor is OUES, right? So it will show you a table with only one predictor. Now let's create another block. If you want to add another variable, little by little, you need to click on Add New Block. In my block 2, I'm going to drag OUES. Oh, can I do it? Oh, it has to be separated. Okay. I'm going to add VO2 peak. Oh, yeah, it does automatically. And now I have OUES and VO2 peak as predictors. So I have 2 predictors. Now, in my second block, in my third block, I'm gonna add, besides that one, oh, sorry, let me just click here, the heart rate, right? Look at this, it's building up the model little by little. In my fourth block, I'm gonna add age. Now the model is becoming more complex, right? Now I have OUS, VO2 peak, heart rate max, and age. Now let's add another one in my fifth block. Now let's add fat total. And again, it is updated. If you want to access the table for each model, you have to click here on this tab. So it will show you the model 1 that had only OUES, model 2 has OUES and VO2 peak, and so on, right? So you will have as many tabs as many models you are building up. Now let's add another block, because I need to add a stroke color. Now I have a stroke color here. And finally, in my new block, let's add female, right? And female is right here. And finally, this is my full model. This is the model. What I did was to take all these variables and just build up the model little by little. Now, look at this. It will give you the model comparisons table. And this model comparisons table is actually missing. Let me just go to model fit and ask for the AIC. You have to click here. And look at that. It will give you the R-square and the AIC. So it's telling me that according to the solution, right? Remember, I kind of changed the model a little bit from the model that I did in R, just for fun. But it's the same procedure, it's the same logic for any model that you will run in Jamovi. So look at this. And the first model, remember that the first model was a model where, let me show you here in the table. The first model had OUES as your only predictor. And actually, I should highlight that here. You can see it right here. So it's very tiny. So it's the only predictor. And look at the AIC value. It's very big. It's 1,000. But if I add a predictor, such as, for example, in my second model, I added VO2 peak, as you can see here. When I add that model, sorry, that variable, the AIC decreases. It goes down. Why is that happening? Well, that is happening because the model with two predictors, OUES and VO2 peak, is better than the model with only one predictor, and that predictor was OUES alone, right? So it's telling me that the model gets better. If this AIC number gets smaller, that means that that model is better, right? So if you see the pattern, in this case, the AIC goes down, goes down, goes down, and the final model is actually better than the other models because the AIC is 925, right? Compared to 992, for example. So that means that by adding all these variables in the final model, the biggest model that I can run, right? According to the list of variables that I gave right here to the software, right? This model is the best model according to the AIC value, right? Right here. You will also have the R square. If the R square is larger, that means that your model is better, right? So look at the R square here. This one is very tiny. This is 0.000000129. So it's a lot of zeros. So it's a very tiny R square. But if you go down, if you continuously add more variables, look at that. You get 48% of variance explained. That's good. That's a very good model, actually. And this model is explaining a lot, 48%, right? The R square is 0.48, which is wonderful, right? So now we know that the final model, the seventh model, is actually the best model. And actually, I'm amazed that by serendipity, I did it. I was just picking some variables here. And now, let's interpret the final model. So in this case, heart rate is actually explaining a lot. Oh, look at that. Heart rate is explaining, well, not a lot, but a little bit. You can see the standardized solution by clicking here. And look at that. This is the standardized estimate. Why do we care about standardization? Well, because all these variables are in a different metric, right? They have a different combination of values because, of course, age doesn't follow the same distribution of values compared to heart rate, for example, right? So if you want to compare which one is or which one has a larger relationship with digital symbols, in this case, which is my outcome, you have to standardize your outcome. Sorry, your estimate. So in this case, the Stroop color is actually predicting a lot, right? It says that the relationship between Stroop color and digital symbols is 0.46. It's like a correlation. Remember, when it is standardized, the number will go from -1 to 1, like a correlation, right? So it's telling me that this relationship is very strong compared to the correlation of OUES and digital symbols, right? It's very tiny. It's -0.0007, right? Well, 0.0008. So the relationship is very tiny. It's actually produced by randomness. And the p-value of this relationship is very big. So it's telling me that the relationship of OUES and digital symbols is explained by chance. right? While the relationship between strobe color and digital symbols is not explained by chance, because the p-value right here, this p-value right here, is way lower than 0.05, right? So it's not explained by chance. This one is explained by chance. This one is fact total. So now we know that the total fact is not related to the performance on digital symbols, right? So that one is not it's just explained by chance. And this one right here, H, well, it's almost explaining. Actually, I would keep H because it kind of tries to explain something. And VO2 peak is also not explaining anything. But look at this. The maximum heart rate during the 6-minute walk is actually explaining something, right? So it's telling me that at least the cardiovascular fitness as measured by the 6-minute walk is a predictor of the performance on digital symbols, which means it's a predictor on working memory, right? The better you do in this test, because the slope is positive, look at that. The better you do in this test, the better your working memory score will be, right? Because the slope is positive, right? If you walk more distance in this test, you will get a better score in the digital symbol test, right? Which is something that I was expecting, and it looks good, right? And let's take a look in terms of gender. Well, the difference in gender is explained by chance. In this case, this is the mean difference, right? It's telling me that in this data set, let me check if one is female. So it's telling me that females have a lower performance on the digital span, the digital symbol test compared to men, right? But that difference is explained by chance. So to be honest, it doesn't matter too much, right? It's just explained by chance. So that happens sometimes. By chance, you might get a difference between gender, and it could be just explained by chance. So this is the best model that you can get if you follow the procedure that Jamovi provides, right? And how do you answer this? This is the hard part. You would have to click on this tab, and let me just erase this. If you are using Word, you will have to copy this table just with right click, copy. Let me open a new file here. If you're using Word or Google Docs, you will have to copy the table and just tell me that this is model 1. Oh, of course, you don't have to use this, right? It's just I got used to this, right? And then model 2, you have to go here. Oh, sorry, go here and paste the next table and create a title that says model number 2, model number 3, so I can see what you did, right? That's the only way I can see what you did, if you copy each table and put it there. And also, you would have to copy this table. The model fit measures, it's very important because I need to know the values for each model that you run, right? It doesn't have to be 7 models. You can run as many models as you want because we have more variables in the dataset. I just picked those ones as an example, but you can pick more. And you don't have to use, remember, you don't have to use, for example, digital symbols as your outcome. It could be any other outcome, right? But of course, don't do this with weird variables. Like, for example, don't predict age. Age is not a variable that you predict. It's not an outcome. Age, sorry, is always a predictor, right? Don't add H right here, right? H should be here all the time. Other variables that could be outcome could be, for example, trail B. And also, let me see how it looks like. Trail B, actually in trail B, oh yeah, the best model is the 7th model, right? Oh. So in trail B, the situation is kind of interesting. Yeah, stroke color still explains a lot. So yeah, you can change here the outcome, right? Or dependent variable, but it has to make sense, you know? Now, another thing that it might pop up in your mind when you're answering this question, and is, can I use a cognitive variable, right? A cognitive test as a dependent variable, right? Sorry, can I use a physical performance variable? Like, for example, VO2 peak, right? Can I use VO2 peak here? Let's do that. Let me just graph VO2 peak is right here. Let me remove it and put it here. So can I use VO2 peak? Can I predict physical performance with cognitive scores, right? Well, that would be a very good question. That's kind of the question of the chicken and the egg, right? And that's something that we have this conversation in health psychology and also in health-related fields. Because we ask the question of, is it the case that people with better mental abilities, is it the case that they are more prone to do more physical exercise compared to people who have less abilities at the cognitive level, right? So if we answer that question, of course, we can use any variable of physical performance as an outcome and predict that physical performance with cognitive test, right? Because it could make sense. Why? Because people who are better, for example, in working memory tests, probably are more organized, and they organize better their lives, and they administrate better their time, and they make up time for doing exercise, right? It could be, right? The opposite is also true. If you do more exercise, your cognitive performance is better, right? We already know that. But the other way around could make sense. However, what we have seen in experiments most often is that you first improve your physical activity, and then your cognition gets better, right? Your cognitive tests go better, and by getting better, you are more prone to be engaged in physical activity because you feel better, mentally speaking, and also you are better at organizing the information that you get out of your environment. So after conducting experiments, what we found out is that, yeah, any physical fitness variable is a predictor of cognitive performance, right? However, the other way around could work, but you kind of have to have a special case for that. But the problem is that we are studying or trying to isolate something that is more like a system, right? It's more like a system of events happening, right? So it's kind of hard to isolate the system, but this is the best that we have done so far in science, right? Um, I don't know if you have any question so far. Everything good? All right, people, then I will leave you alone. I spent a lot of time answering this question, but it was important for me, at least for me. I don't know, just make me happy. No, I'm kidding. Don't make me happy. But I feel happy that I could add this type of topics, and hopefully will help you, at least in the seminars when you have to run different models once you do your own research project. So if you don't have questions, I'll let you go. Thank you so much, and see you face to face, right? On Thursday. Only if I'm sick. My pleasure, Denise, my pleasure. And thank you, Leila. If I get sick for something, I will send you an email. But I'm not anticipating I'm gonna feel bad on Thursday. But yeah, see you Thursday, face to face. Thank you so much. Take care, Jennifer. Take care. You too.